Alright guys, this is the probably long-awaited Chapter 8 review video. So, I'll be honest, it's probably going to be quick because I want to get this over with. Alright, so in these first couple problems, we're just going to be solving the triangles. So solve each triangle and round the side lengths to the nearest tenth. I honestly don't care too much as to where you round. Angles to whole numbers, again, I don't really care too much. So, solve each triangle. So, meaning to find all side lengths and all sides. Obviously, you have to be given some of the information, so you're not finding all six sides and all three sides and all three angles. So in this case, we have an angle, and we have we know that's 90 degrees, and then we have this side. So we're missing angle B. We need this side, and we need this side right here. And just so you guys are aware, so that you guys know, typically, as far as notation goes, this is angle A, and opposite to angle A is side A. This is angle B, and opposite to angle B is side B. So if you want to label accordingly, that's usually how I label. So this is A, and this is B. And we usually refer to the hypotenuse as C. Alright, so I'm going to start with finding angle B because I already know two of the angles right here. I also know that the acute angles here will add to be 90. So if I do 90, subtract 74. So those two right there. If I do 90, subtract 74, that's going to give me 16. So I know that angle B is going to be 16 degrees. So now all the angles are solved for. Now as for the sides, it really depends on how you want to use your trig function. So we can't use Pythagorean theorem because we only know one side, and we don't know either of these ones. So we can't use Pythagorean theorem. This is the hypotenuse, right? So this is the hypotenuse. Regardless of which angle you use, this is the hypotenuse. So there are two trig ratios I can use. So sine uses the hypotenuse over, sine of an angle theta is equal to the opposite over the hypotenuse, and cosine of theta is equal to the adjacent over the hypotenuse. So I can use either of these two with one of these angles right here. Doesn't matter which angle, doesn't matter if it's sine or cosine, as long as we're using the hypotenuse and one of these two sides. One thing that we cannot use is tangent. We can't use tangent because if I use tangent of this angle, for example, tangent is equal to the opposite over the adjacent, and so that would give me B divided by A. And then if I use tangent of 74, that would be A divided by B. Either case, I get two unknown sides. I can't have two unknown sides. I have to have one known and one unknown. Okay, so I'm just going to pick at random. Let's do sine of 16. So sine of 16 would be equal to side B, because that's the side opposite to angle B, and then over the hypotenuse, and the hypotenuse is 8. And there you go. So now I just have to solve for side B. So to do that, I just have to multiply both sides by 8. Those cancel. So then I get B is equal to 8 times by sine of 16. And then you just have to use your calculator. Make sure that your calculator is in degrees. So we'll do 8 times by sine of 16. Enter. And in my calculator, I got 2 point, we'll just say 2.2. So that's what this side is right there, 2.2. And now, if you want to, you can use Pythagorean theorem, because I know this side now, and I know this side. You can solve for that using Pythagorean theorem. I think it's just easier to use a trig function, though. So, now, I'll go back to using the same angle, but instead of sine, this time, I'll use cosine, since I used sine before. So, cosine of angle 16. Okay, so here's angle 16. Well, cosine is adjacent. Adjacent to 16 is side A, which is unknown, and over the hypotenuse, which is 8. So it's going to be A divided by 16, or sorry, divided by 8. Do the same thing. I'm just going to multiply both sides by 8. Okay, and those are going to cancel. So I'm going to get A is equal to 8 times by cosine of 16. So 8 times by cosine of 16. Whoops. 8 times by cosine of 16, and I got 7.7 if you want to round to that decimal point right there. Okay, and there you go. So I have all of them solved for. Let's try, you know what? I'm going to let you guys try 2. I'm going to go and do 3. 3 will be pretty similar. Okay, so yeah, let's try B. So I have this angle right here, and I need this angle. Oh, look. That's kind of funny. Sorry, in any case, I was just thinking. Okay, so this right here is going to be 74. This angle right here will be 74, kind of like in this one right here. Yeah, these are going to have the same ratios, different side lengths, but same ratios. Any case, you guys don't need to worry about that. Okay, so let's do the same thing. So let's say that I wanted to use cosine of 16. Well, I'd be careful about using cosine. Let me label my sides again. This will be side B. This time we're given this side, which is side A, and then this side right here is going to be C. Okay, so I don't know the hypotenuse as opposed to in this one where I had the hypotenuse and the sides were unknown. Here, I don't know the hypotenuse, I have one of the sides. So if I were to do cosine of 16, that would be equal to the adjacent side, which would be B, over the hypotenuse, which is C. So you see that this one won't work this time around because I do not have the hypotenuse or the adjacent side for this angle right here. So if I'm going to use cosine, I would have to use cosine of B. So cosine of B, or sorry, cosine of 74, since we know that angle, that would be equal to the adjacent side, which is 12, divided by C. Okay, if I'm using angle A, I would have to use sine of 16, which would give me 12 over C. Either one of those. Or I can use tangent of either one of these angles. But I'm going to stick with sine. So let's say I do sine of 16. Sine of 16 would be the opposite side to this angle, which would be 12 divided by C. So divide by C. Okay, so now the problem with this one and the difference between the problem that we did before and this one is that our unknown side length is in the denominator as opposed to up here. Either time that we used our trig function, the unknown side length was in the numerator. Okay, so we're not going to do anything too crazy. We're just going to solve it like we would any other problem. We don't want the unknown variable in the denominator, so multiply both sides by C. So that gets rid of it out of the denominator here, puts it in the numerator over here. So now we're in the numerator. We get C times by sine of 16, which is going to be equal to 12. That's time, sorry, by the way. Well, okay, well I still want C by itself. I want it in the numerator and by itself. So now I'm just going to divide by sine of 16, divide by sine of 16. So then I'm going to get C is equal to 12 divided by sine of 16. So this time, instead of multiplying by whatever I have, just like up here, 8 times by cosine, 8 times by sine, now it's going to be 12 divided by sine of 16. So in my calculator, I'll do 12 divided by sine of 16, and I get 43.5. So there you go. My hypotenuse is 43.5. Okay, now if I want to find the side B, I can just use cosine, or I can use pretty much anything else because this is the last thing I need. So I can use tangent of A, I can use tangent of B, I can use sine of B, I can use cosine of A. I'm going to go with cosine of A. So cosine of A, which is 16, is going to be equal to, you know what, I'm not going to use that. Let's go with tangent. Yeah, let's do tangent. So tangent of 16. So tangent of 16, which tangent is opposite over adjacent, so this is going to be 12 divided by B. So again, I have B in my denominator. I'll do the same process. I'll multiply by b so that it's no longer in the denominator and it's in the numerator on the other side. So I get b times by tangent of 16, and that's going to be equal to 12. And then I'm going to divide by tangent of 16, divide by tangent of 16. So then I get b is equal to 12 divided by tangent of 16, which is going to be equal to 12 divided by tangent of 16, which is going to be equal to 41.8. So there are my two sides. Okay, now I'll move on to 4. So for 4, this one's going to be different because as opposed to 1 through 3, we were given a side length. In this case, we're given two side lengths but no angles inside. Here we were given a side length and an angle. So we're given different information, so we have to make do with what we have and using different methods. So first thing I'm going to do is solve for this missing side using Pythagorean theorem. So Pythagorean theorem, in this case, 12 squared will be equal to 10.9 squared plus b squared. So we're going to subtract 10.9 squared, subtract 10.9 squared from both sides. So 12 squared, subtract 10.9 squared, and I get 25.19 is equal to b squared, and then I'm going to take the square root both of them, so I get b is equal to the square root of 25.19, which is 5.01. Just for the sake of making it easier, we'll just say 5. How about that? I don't really care. If you use 5.01, your angles might be slightly different, but not enough to make a difference. Okay, so I wouldn't worry about it. Okay, so now let's solve for the angles. Well, I can't use the theorem of the sum of the triangle to be 180 because I only know that this is 90, so really don't know how I could do that here. So I'm going to use a trig ratio. So since I know all my sides, it doesn't really matter which of these two angles I'm going to use. I can use A or B, and because I know all the sides, it doesn't matter if I use sine, cosine, or tangent. Really, just you can just pick one at random as long as you use them correctly. So I'm just going to use sine of A. Okay, and then just follow through with what this means. Sine means opposite over hypotenuse. So in this case, if I'm using A, opposite is 5 and hypotenuse is 12. So you just have to make sure that you follow through with that ratio. Okay, and then in order to get rid of this sign, because I'm solving for this variable, that's what I want. I don't want that sign there, because A represents my angle. So to get rid of sine, use the inverse of sine on both sides. That will cancel out with here, leaving me with just A, and then I'm going to get sine inverse of 5 divided by 12. Okay, sine inverse of 5 divided by 12. Well, let's go to my calculator. I'll show you that your calculator will have these two buttons. So if you press the second button, and then if you see sine here, right there. If you press it, as long as you press second before, you'll see that you get the sine inverse. And then I just have to type in the ratio that I had in there. So 5 divided by 12. So 5 divided by 12. I need to make sure that I am in degrees. Okay, so I'm in degrees. Let me redo that. Sine of 5 divided by 12. I get 24.6. So A is 24.6. Okay, well, now to solve this one, I'm just going to do 90 minus 24.6. So 90 minus 24.6, that's going to be 65.4. Okay, and then you're done with that one. Alright, so try doing the same thing with one of these ones. Just use Pythagorean theorem, solve for this side, and then to solve for one of these angles, just use sine or cosine. Tangent, it does not matter, because you'll have all your sides. It won't matter. And then just do the inverse of whichever one you picked of the ratio of those two sides, and you'll get your angle. Okay? Alright, moving forward. Find a positive and a negative coterminal angle for each of the given angles. So you should have two answers here. Find one positive and one negative coterminal angle for each given angle. So to find something that's coterminal, if I can illustrate it really quickly. Okay, so say that we have an angle. Say that we have this angle right here. Just an arbitrary, random angle. Okay, so this angle right here, if I rotate 360 degrees from that angle, I'll be in the same spot in either direction. If I rotate 360 this way, if I rotate 360 this way. If I rotate 360 this way, I can rotate another 360 degrees and I'd have another coterminal angle. If I rotate another 360 degrees, I'll have another coterminal angle. So coterminal angle just means that you have a different angle, meaning that it rotated either a different direction here or it rotated more than once to get to the same spot. But in either case, a coterminal angle just means two different angles that share the same terminal side. That's all it means. So you get coterminal angles by rotating 360 degrees from wherever the angle is measured from. So I'll start with A. So negative 190. So just to kind of give you an illustration, you don't have to draw this on your test at all. But so negative 190, so negative means I'm going to rotate this way, so this is negative 180, so this right here would be negative 190. So negative 190 degrees. Okay, so the question says give it a positive coterminal angle. If I want a positive coterminal angle that's going to be coterminal with this right here, I'm going to rotate 360 degrees from here. So all I'm going to do is add 360 degrees to 190, so negative 190. So negative 190 plus 360, and that's going to give me 170. So 170 degrees. Okay, and then if I do negative 190, and then if I want a negative coterminal angle, so then I'm going to rotate another 360 degrees in the negative direction. So I'll subtract 360 degrees from that. So negative 190 minus 360, and that's going to give me negative 550. There you go. You have one that's positive, you have one that's negative. Okay? It's no different here whenever I go to radians. But if you're given this in radians, your answer also needs to be in radians. So we just have to think about rotating 360 degrees, but in radians. And 360 degrees is equivalent to 2 pi radians. So instead here, I'm just going to add, well, actually, I'm going to start with subtracting. And I'll tell you why in just a second. So I'm going to subtract 2 pi radians. Now, so this is the equivalency to subtracting 360 degrees. That's essentially what I'm doing with this angle right here. Okay? Now, the reason why I'm subtracting is because I already know that this angle right here actually rotated rotated more than 360 degrees. The reason why I know that this right here is more than 360 degrees is because 360 degrees is equal to 2 pi radians, right? 29 over 12 is greater than 2. So 29 over 12 pi is greater than 360 degrees because so let's say if it was 24 pi over 12 is the same thing as 2 pi. So because this number is greater than 24, I know that this right here has rotated more than 360 degrees. So if I subtract 2 pi, I know that I'm still going to have something that's positive. Okay, so let's subtract 2 pi. In order to subtract these, they have to have a common denominator. So I'm going to multiply the top and bottom here by 12. So 29 pi over 12 minus, now it's 24 pi over 12, which again is the same thing as 360 degrees because this is 2 pi. So 29 minus 24 is going to be equal to 5. So 5 pi over 12. Okay, so here is a coterminal angle to 29 pi over 12, but this is positive. And the reason it's positive is because this angle was larger than 360 degrees. So I subtracted 2 pi, which is 360 degrees, so I'm staying positive. So now if I want a negative coterminal angle, I'm going to take 5 pi over 12, and I'm going to subtract 24 pi again. So 5 minus 24, that's going to be negative 19. So negative 19 pi over 12. So now I have one positive and one negative. It's the same thing as if I had like 400 degrees, and if I were to find a positive and a negative coterminal here. Thing is, if I subtract 360 from this, so if I subtract 360 from 400, I get 40 degrees. Well, this is still positive, so then if I want a negative, I'm going to subtract 360 again. Same concept. Okay. All right. Reference angles. So find the reference angles. So in order to find the reference angle, I need to graph what the angle actually is. So here, let's graph negative 11 pi thirds. So I've explained to you guys many times in class, so I don't think I'm gonna go over it just as much in this video. But if you need to know how to graph, how to draw angles in radians, I would just look up in YouTube how to draw angles using radians. And maybe someone else has a different explanation or better explanation than what I did, but I'm not going to cover it too much in this video because I've done it a lot in class. So pi over 3. So I do know that pi itself is equivalent to 180 degrees. Okay, so this right here is 180 degrees, and I'm splitting it up into thirds. So you can think about it like that. There's a third. So we got 1, 2, 3. Split this one up right here. We'll have 4, we'll have 5, we'll have 6. So this would be 3 pi over 3. So this piece alone would be a pi thirds. This piece also would be a pi thirds. This piece also would be a pi thirds. Each of these portions right here is a pi thirds. Pi thirds, pi thirds, pi thirds, pi thirds. Okay, now we're also negative. So that if I look to my denominator and look how many times each half is being split up, it's being split up 3 times, and then this tells me how many pieces I need. This tells me which direction, right? So I'm rotating this way. So here I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's where my terminal side is going to end up. It's going to end up right here. And to show the path, because just so you know, we'll go around once and then back right here. So this angle right here is negative 11 pi thirds. Okay, and the reference angle is going to be this angle right here. Reference angle is always to the closest x-axis. So that would be this angle, and look, it's pi thirds. There you go. So this denotes reference angle. That's going to be pi thirds. Okay, 290. So just for illustration, let's see if we can just graph this right here. So 290. Well, I know if I rotate this much right here, that's going to be 90. That right there is going to be 180, and this right here is going to be 270. So I need to go 20 degrees more. So I know that my angle will be 20 degrees beyond this right there. So this right here is going to be 290 degrees. And then my reference angle is always the angle to the closest x-axis. Well, if this was 20 degrees, this has to be 70 degrees. So there's my reference angle. Okay. All right, we have another radians. Okay. So just using the technique that I showed you above, hopefully you guys like it. It's something that's always worked for me. Hopefully it works for you guys, but I've always liked it. Okay, so we're going to rotate. Imagine that we have 9 halves, so 9 parts on each half. So 9, then again, that's going to be 18. That's going to be 27. And then 27 plus 9 is going to be 36. Well, I don't want 36. I want 2 less than 36. But there you go. You kind of just answered the question right there. So if I rotate right here, so rotating around here, if I rotate just to there, that's going to be 9, 18, 27, 36. I want 2 less than that. That's going to be 2 parts. Imagine that we have 9 parts in this half right here. Go back 2 right here. So this right here would be 2 of those parts. So 2 pi over 9. So that's your reference angle right there. So this angle right here, where we went around once, or we went around once, and then almost 2 times. This right here is 34 pi over 9, but in order to get to 36, we would have had to go 2 more parts. Well, therefore, that's our reference angle right there. Okay? And then going here, negative 145 degrees, negative 145. So we have to rotate this way because it's negative. This right here would be 90. This right here would be 180. So it's got to be less than that. So I think it would have to be just probably like right here. This right here would be negative 145. Well, I do know that the total has to be negative 180. So what's the difference between 180 and 145? And that's just going to be, I think it's going to be 35. Yeah, 35. So this is my reference angle, 35 degrees. Okay, remember, just always to the closest x-axis. Okay, convert each radian measure into degrees. So for this one right here, these are radian measures. I want to convert them to degrees. So simply put, I'm going to multiply. Again, we've covered this in class, so I'm not going to cover too much as to why you do this. You can look at some notes or look up a video. But I'm going to multiply by 180 divided by pi if I want to get radians into degrees. So the radians are going to cancel. So then I'm just going to get on the numerator 11 times by 180, and on the denominator 3. So if I multiply that on my calculator, 11 times by 180, and I divide that number by 3, I get 660 degrees. Okay, same thing here. I'm going to multiply by 180 divided by pi. The pi's are going to cancel because there's one in the numerator, one in the denominator. This is negative 25 times by 180 divided by 36. So 25 times by 180, and then divide that by 36, and I get negative 125 degrees. Okay, now if I'm going the other way, where I have degree measure, I'm going to multiply by pi divided by 180 degrees. In this case, the degrees are going to cancel. So the degrees are going to cancel. The degrees are going to cancel. Okay, so then I get negative 855 pi divided by 180. You have to reduce this. So 855, let's see, 855 is divisible by 15 at the very least, I know. I think 180 is also divisible by 15. Yeah. So if I divide those by 15, I get negative 57 pi divided by 12. I think those are, so 57 is divisible by 3. So then I'm going to get negative 19 pi. 12 is also divisible by 3. That's going to give me 4. So there's my radian measure right there. So make sure you answer with a ratio, not in decimals. So I'll do the same thing here. I'm going to multiply by pi over 180 degrees. Well, the degrees are going to cancel, and now I'm going to be in radians. Okay, so I get 200 pi divided by 180. At the very least, I know those are both divisible by 10. That's 20 pi divided by 18. I know both of those are divisible by 2. I get 10 pi divided by 9. There you go. Okay, for arc length, S, I don't know why they use S, but they'll say S is equal to R times by theta. R is the radius, and theta is the angle in radians, though. It's got to be in radians. Okay, so, well, look at here. We have the radius, and we have the theta, but this one's in degrees. Okay, so I know S here is going to be equal to 8 times by, I can't use 60 because this is in degrees. It needs to be in radians. Yes, you can go through this process right here and multiply by pi over 180. But if you 60 degrees, I hope that you guys know that that is equivalent to pi thirds. It's just kind of something that you should, I don't know, not through memorization, but through repetition. We should have used that enough. 60 degrees is equivalent to pi thirds. So 8 pi, and then you divide that by 3. So the arc length here, remember the arc length we're referring to is this piece right here. That's what I want. This is equal to 8.38 meters, I guess I should say. Okay, and then for this one right here, we'll do S is equal to the radius, which is 7, times by, well, looky here, this one's already in radians, so just 5 pi over 3. Okay, so 7 times by 5, I think that's 35 pi over 3. So 35 pi, and then we're going to divide that by 3, and then we're going to get 36.7 kilometers. So that's how long this arc is right here. Okay, I'm going to make a second video for the non-calculator portion.